Welcome to Grade 7 Mathematics. In this lesson, we'll explore linear equations, the tool we use to find an unknown number hidden inside a problem. By the end, you'll solve equations step by step and turn everyday situations into equations you can solve with confidence. Here is our plan for the lesson. We'll first picture an equation as a balance that must stay level. Then we'll solve one-step and two-step equations. We'll open up brackets and deal with a variable that appears on both sides. Finally, we'll turn real-world word problems into equations we can solve. Think of an equation as a balance scale. The equals sign in the middle means the two sides weigh exactly the same. On the left pan we have x plus 2, and on the right pan we have 5. Because the scale is level, x plus 2 must equal 5. Here is the golden rule of equations. Whatever we do to one side, we must do to the other, so the balance stays level. If we take 2 away from the left pan, we take 2 away from the right pan too, and the scale stays balanced. That single idea is the key to solving every equation ahead. A one-step equation takes a single move to solve. Solve x plus 7 equals 12. Our goal is always to get x by itself on one side. Right now 7 is added to x, so we undo that by subtracting 7 from both sides. On the left, x plus 7 minus 7 leaves just x. On the right, 12 minus 7 is 5. So x equals 5. We undo addition with subtraction, and we undo multiplication with division. A two-step equation needs two moves. Solve 2x plus 3 equals 11. We undo the operations in reverse order. First, we deal with the addition, so we subtract 3 from both sides, leaving 2x equals 8. Then we deal with the multiplication. 2x means 2 times x, so we divide both sides by 2. 8 divided by 2 is 4, so x equals 4. Undo the adding and subtracting first, then the multiplying and dividing. When an equation has brackets, we open them up first. Solve 3 times the quantity x minus 4 equals 18. We expand the bracket by multiplying everything inside it by 3. 3 times x is 3x, and 3 times negative 4 is negative 12. So we have 3x minus 12 equals 18. Now it is a two-step equation. We add 12 to both sides, giving 3x equals 30. Then we divide both sides by 3, so x equals 10. Sometimes the variable appears on both sides. Solve 5x plus 2 equals 3x plus 10. Our first job is to gather the x terms onto one side. We subtract 3x from both sides. 5x minus 3x is 2x, so the left becomes 2x plus 2, and the right becomes 10. From here, it is a two-step equation. Subtract 2 from both sides to get 2x equals 8. Then divide by 2, so x equals 4. The real power of equations is solving everyday problems. Suppose 3 pens cost 1,500 Rwandan francs, and we want the cost of a single pen. First, we choose a letter for the unknown. Let x be the cost of 1 pen. 3 pens cost 3 times x, so 3x equals 1,500. We divide both sides by 3, and 1,500 divided by 3 is 500. So 1 pen costs 500 francs. Equations are all around us in daily life. When you send mobile money, an equation links your old balance, the amount sent, and the balance that remains. At the market, if a sack of beans has a known total price, an equation gives the price for each kilogram. A bus journey links the total fare to the fare for each stop. And when saving toward a goal, an equation tells you how many weeks it will take. Whenever one quantity is unknown but tied to known amounts, an equation finds it. Before we practice, let's avoid the traps that catch most learners. First, always change both sides of the equation, never only one. That is what keeps the balance level. Second, keep each sign attached to its number, so a negative 4 stays negative as you move it. Third, expand any brackets before you start collecting terms. And finally, check your answer by putting it back into the original equation. If both sides come out equal, you know your solution is correct. Here is a quick summary of the key ideas. An equation is a balance where both sides are equal. To stay balanced, we do the same thing to both sides. We get the variable alone using inverse operations. With brackets, we expand first, then collect terms, then solve. When the variable is on both sides, we move all the variable terms together. And for word problems, we name the unknown, then write the equation. Now, let's check how much you remember with 3 quick questions. Here's the first question. Solve x minus 6 equals 9. 6 is subtracted from x, so we add 6 to both sides. 9 plus 6 is 15, so x equals 15. Question 2. Solve 4x minus 5 equals 19. First, we add 5 to both sides, giving 4x equals 24. Then we divide both sides by 4, so x equals 6. Last question, and it combines several ideas. Solve 2 times the quantity x plus 3 equals x plus 11. Expand the bracket to get 2x plus 6 equals x plus 11. Subtract x from both sides, leaving x plus 6 equals 11. Then subtract 6, so x equals 5. Wonderful work. You can now picture an equation as a balance, solve it step by step, and build equations from real problems. Take a moment to try a few on your own. In Module 6, we'll explore geometry, starting with lines and angles. I'll see you there.